Hi. In the last couple of videos, we looked at using first principles to find the derivatives of functions. But first principles are all very well, but it can be very time consuming and it's really easy to make mistakes. So it's really good if we could find a better way. And we can do that. There are basically 5 main rules of differentiation that make that task much easier. And we're going to have a look at them in the next couple of videos. So the first one is the power rule, and this one's really easy. And we use this one when we've got a variable raised to a power. So for example, f of x equals 4x cubed. So x is our variable raised to the power 3. Now, we can use first principles to find the rule for the general case of f of x equals ax to the n. And again, we have that same basic structure. So we have a times x plus h to the n minus ax to the n all over h. And then we finish up with this. And what I've used here is a thing called binomial expansion. Binomial, 2 numbers to a power. And expanding that out. When it's 2, we've seen that's really easy, but this is for the nth case. And basically you'll notice that the powers of x go down, so we've got n minus 1, n minus 2, n minus 3, all the way down to 2, 1, and in fact x to the 0 here, which is 1, so it doesn't appear. And h actually goes the other way. So it starts at 0 and goes up to n. And then these numbers here, these coefficients, they are actually the numbers from a line in Pascal's triangle. And it depends on what that power is as to how far down Pascal's triangle you go. If it was squared, then the coefficients would be 1, 2, 1. If it's cubed, it would be 1, 3, 3, 1. If it's 4, it's 1, 4, 6, 4, 1, and so on. So they're just coefficients. How they come about, you don't need to worry about terribly much here. It's just showing what happens. Okay, what I've done here, if you like, I've expanded through by a, but then I've said, okay, ignoring that first one, I've taken a outside again. So I've got my ax to the n plus a times all of that stuff that's left. And surprisingly, we've got ax to the n minus ax to the n. And everything else in here has got an h involved with it. So I can take my h outside the bracket and it cancels out. And what we're left with, again, everything in here except this very first term has got an h. So these all disappear. And we're just left with that. Now, n1, this number here, is always n. So there it is. So the derivative, the power rule says that derivative of ax to the n is anx to the n minus 1. The n drops down in front and it goes down by 1. So let's have a look at some examples. 2x squared, really easy. We take the 2, we multiply it by whatever's out the front, in this case 2, and then that goes down by 1, so it's x to the 1. In other words, just 4x. This one here, 3 times 2 is 6 squared. This is 5 to the 1, so it's 5 times 1, times x to the 0. X to the 0 is 1, so it's just 5. Whenever you find the derivative, finding the derivative of a times x, it's always just a. And here we have a constant. And the derivative of a constant is always 0, so it just disappears when you take the derivative. So we finish up in this case with 6x squared plus 5. It also works with negatives. So we've got 5x to the minus 5. Well, that's going to become minus 25 when we multiply that by 5. times x to the, well, minus 5 minus 1 is not minus 4, it's minus 6. We're still going down. And then likewise this one, minus 2 times 3, so we have minus 6x to the minus 3. That's all there is with the power rule. Really easy to use. It is the simplest, and it's sort of the backbone of everything you do with all of the other ones. The next one is the product rule. And we use that when we differentiate two functions that have been multiplied together. So for example, this one here. Here's one function, here's another function. So f of x is made up by multiplying u of x, which I've used the first one, I've called that one u of x. I've called the second one v of x. We could expand them, and we could use the power rule. But again, that's likely or more likely for you to make mistakes. So there's a better way of doing it. And again, we can actually prove it using first principles. So if f of x is this thing here, u of x times v of x, then f dashed is the limit as x approaches 0 of u of x plus h times v of x plus h minus u of x times v of x all over h. Now, what I've done here, I've taken away u of x times v of x plus h. But then I've added it back in again, plus u of x times v of x plus h. In other words, I haven't actually changed anything. But by putting these two in, we can actually change the format of this and make it really easy to work out. I'm going to remove this v of x plus h from these two, and I'm going to remove u of x from these two. And that's what we get left with. So we've got v of x plus h times u of x plus h minus u of x all over h. That sounds like the derivative of u to me. That's u dashed. And then here we've got u of x times v of x plus h minus v of x all over h. Again, that's v dashed. One of the nice things with limits is we can actually split them up into two bits. So this bit here, this is u dashed. And because we're not dividing by h anywhere here, by putting in h equals 0, we're just left with v of x. So we've got u dashed times v. And then over here, we've got u times v dashed. And that is the product rule. So how do we use it? Well, if f of x equals this thing here, here's u, here's v. So derivative of u is 6x plus 2 multiplied by v. And then it's u multiplied by the derivative, so it's 3x squared plus 2x minus 3. Most of the time, you can leave it in that form. You don't have to simplify. What about this one? Well, here we have to remember that the square root of x is actually x to the power of a half. And then we can just use the power rule. The fact that it's a fraction doesn't make any difference. So the derivative of x to the half, we drop the half out the front, and then it's x to the half minus 1, or minus a half. Multiply that by v of x. Well, the derivative of v of x is just 5, so it's just 5 times root x for the last little bit. And that's the product rule. Very useful and helpful. And the next video, we'll look at the next couple of rules.